Section 3.3 is vectors in the plane, and vectors are something that are very important to us in a physics class, something that will be used on a very regular basis. And so when we're talking about a vector, what we're talking about is a directed line segment. And it's more than just a number. It tells us magnitude, okay, and direction that we're moving or that we're working on or working with in our situation, whether we're talking about a force, whether we're talking about the trajectory of a projectile, whatever the case may be. When we're drawing a vector, maybe I can use my tools here. It has a terminal point, an initial point, and a terminal point. And so the initial point is our starting point. That says initial. And the terminal point is where it ends. Okay, different than just a regular line segment, these line segments are directed. So, for example, my underline under the word directed is just a line segment. And I can move that line segment anywhere, and it's different over here than it is over here than it is down here. Okay. Our directed line segment has a starting position, it has an ending or a terminal position. Maybe need to put the word point on there. And it specifically goes in this direction for that amount of time or that length. When we want to talk about the magnitude of our vector, we will use double bars, so it will look like absolute values, only there will be 2 of them instead of 1. When we're talking about a vector, oftentimes we use a boldface letter. When you see a bold-faced U or V, W, those are common vector names in your book. That means vector U or vector V or vector W. Because I can't draw boldface on my paper, I can draw the little vector arrow over the top of it. Or maybe if I know my initial point and my terminal point, they have a name, we can talk about that vector being PQ. Okay, PQ is different from QP. The first letter indicates my initial point, and the second one would indicate my terminal point. Okay. So let's draw a vector here that starts at the point 1, 4. And let's say that that vector ends at the point 2, 0. So we started at the point, maybe I do want to label that. Starts at the point 1, 4 and ends at the point -2, 0. Okay, what we can do is give that vector a name, and the name that it would be if it was in what's called standard position, because any vector on our page, okay, actually let me leave that here. And clone it. Can I infinitely clone it? Okay, only I don't want to infinitely clone this one. Any place that we want to move this vector, doesn't matter where we start it or where we end it, all of these are considered the same vector. Okay, I can put them over here, I can put them up here, I can put them kind of willy-nilly in the middle of space right there. But all of those vectors are equivalent. They have the same direction exactly, and they have the same magnitude, the same length. So if I think about putting that vector starting with its initial point at 0, 0, we call that vector a vector in standard position. So the blue one now is in standard position. Now the way we find standard position for our vector, and when we're writing our vector, we'll call this vector U. Okay, we use pointy brackets We call it the component form of the vector. I had a teacher that called it pointy bracket notation, so I typically will default to that, especially if I'm not being very formal. And it has the first component tells me my change in x, and the second component tells me my change in y. So if I want to find my vector u, I always take the terminal value minus the initial. My ending point, which is at the point, arrow point, minus the dot. So in component form, this vector is -3, -4. Okay. Now, again, let me clone him. If I check any of these vectors here, okay, and I look at them, all of them from their initial point, if I start walking, go to the left 3 steps, and then they go down 4 steps, and that's where I end. All of them go left 3 steps and down 4 steps to get to the end. So no matter where I'm starting, from its initial point to its terminal point, this vector, all of these vectors on the page, in pointy bracket notation or component form are -3, -4. All right, so I'm going to make several shorter videos today. We're going to talk unit vectors, finding magnitudes, scalar multiples, adding and subtracting vectors, all of that in the next video. Okay, I'm going to pick up with this slide when you come back, but I'm going to stop the video here.